So, in this module we will actually be talking about the different kinds of control mechanisms that we have for starting a task and managing a task once it is actually started in the command line. So, as we were discussing earlier, the Unix operating system is sort of supporting true preemptive multitasking. So, now what do we exactly mean by true preemptive multitasking? We will just do a quick recap. So, multitasking is a mechanism by which the system will be able to run in tasks independently and at the same time multiple tasks could be run. And then preemptive essentially means that the system is not going to be allowing one task to be waiting for a long period of time just because another task has been running for a certain amount of time. So, the system is going to preempt the currently running task and give the processor to the another task that is actually waiting for to be running, and thereby the Unix OS is actually treated as a very true preemptive multitasking system. So, it is a mechanism by which I will be able to run multiple tasks in parallel at the same time, and also abort them if they basically try to corrupt any other portion of the memory for which it is actually does not have any rights, right. So, there could be some processes that inadvertently tries to access the memory area of another process for which it does not have a right. So, all those kind of processes will be immediately killed by the OS, not making it run subsequently after that. It also has a mechanism by which it will be able to choose which program should be needed to run at any point in time, and also what input the programs might take and where the output basically goes to. So, this is basically what we were seeing as the input redirection and output redirection as well as error redirection in our earlier module. Now, what exactly is a process in Unix? So, as we were discussing in our earlier module, we said that everything in Unix is a file. Let us put it in a different way, that everything in Unix that is not a file is a process, right. So, what do we mean by this is that a process is something which is actually alive and running on Unix, whereas a file is something that is statically present in some part of my system without having a so called life in it, right. So, it is going to be sort of resident in some corner of my, let us say a storage mechanism, whether it be my pen drive or my hard disk or whatever it is, whereas if that file is, for example, is an executable file and I go start that file by either typing it in the command line or by double clicking on it in my Explorer window, the moment the file is actually read from my hard disk location and then gets loaded into my memory, that file basically magically becomes a running process, right. So, Unix basically now creates a process, copies the content of the executable instructions in the file, makes it as a process, makes it run, and then the beauty here is that I could actually have several instances of the same program running at the same time. So, for example, everybody wants to run the program called ls on the system. So, let us say there are 5 users logged in the system, and at the millisecond granularity time frame, all the 5 users who are logged into the system currently wants to run the same ls command, all of them will be able to execute the same command at the same time, right. So, therein the system basically supports multiple instances of the same program getting executed at the same time in a very seamless manner. So, there are different types of data that is typically associated with the process, which we would have actually seen very briefly when we talked about the different parts of the operating system initially. So, you have what are the open files that are maintained by the process, what is the amount of memory that has been actually allocated, the stack, the process ID being the unique ID identifier that is identified that through which the process is actually identified in the system. So, what is a parent process, what is the priority of the process, what is the current state of the process, like whether it is sleeping or whether it is running or whether it is waiting for IO to complete or whether it is in a zombie state. All those kind of data are associated with each and every process that is actually running in the system. So, because of the fact that Unix is basically supporting multitasking, one very important feature that has actually been made available on Unix is to make a particular task run in the background. Now, what we mean by running in the background is that by default when you type a command in the command line and press the enter key, this command is now going to be read and loaded into memory, and that is going to become a process and starts running. So, by default we tell that this command is actually running in the foreground, because the unless and until the command is completed. So, the command will not be complete without the command getting completed, you will not be able to give any other command or job for the shell to run. So, that is typically what we mean when we say that the command is actually running in the foreground. Now, for the command to run in the background, the main reason for giving this kind of a functionality is that we will understand that there will be certain commands that will actually take a very long time to complete. Now, I would typically be requiring certain other jobs to be done at the same time when this command is being run in the background, so that I do not have to wait for a long period of time for submitting the next command to the system. So, that is basically the reason why the OS is actually supporting a mechanism by which a job could be given to be running in the background, and thereby immediately getting the prompt back for the user to give the next command to the shell. So, if I have this kind of a requirement, how do I typically get it done? I use the ampersand character, what we call as the AND operator also in the programming parlance. I use that character at the end of the line to denote to my shell that this command should be run as part of a background task and not as part of the foreground task. So, whenever I give this kind of ampersand character, the shell will treat it that this command should be run in the background, start this process, make it as a background job, and then immediately come back to the shell prompt, so that the user can basically type the next command or the next tool that he wants to run as part of using the shell. So, that is basically the main advantage and the reason behind why the Unix operating system gives you a mechanism to run a task in the background. So, when I am running multiple tasks in the background, I would need to know at any point in time what are the different tasks that is running. So, especially if I have basically given different tasks and I want to know what is the task that has been given till date and what are the status of each of that, and that is the reason why we have the command called jobs. So, if I say jobs, it will basically return me back and display the list of the current background jobs that is running. So, if out of the listed task, if I want to basically bring any of those tasks to the foreground, I can use the fg command, wherein I say fg followed by the percentage and the number. So, if I want to bring down the second command, I say fg%2, and that number will be the number that is actually getting matched with what is printed as part of the output of my jobs command. So, if I want to bring this second command out as the foreground process, I say fg%2, right, and if I do not give this percent, it basically tries to put the last command that has been given in the background into the foreground. Now, after the task has sufficiently run in the foreground and I want to shift it back into the background, I say Control Z. Control Z essentially is a temporary suspend character, the suspend key that we give in the shell to the currently running process, after which I can type the command called bg. Bg means to put the currently suspended task in the back end, right, in the background. So, this is the equivalent to running the command with the ampersand character at the time of starting the command itself, right. Now, another command that we need to understand as part of the job control is a command called kill, which is typically used to kill the command that is associated with that particular background job. So, if I say kill followed by %1, it will basically try to kill this particular task that has actually been listed as a first process as part of the jobs output. So, that will basically abort the the job that is being passed here, right. So, again an example of how you could typically make use of this. So, if I say kill %1, it reports back terminated and then tells me whatever was the job that was actually given for that particular background task. So, if I want to find out the different processes that are right now running on the system either by myself or on the entire system, I could actually use the -aux option to the ps command or -edf option on some system 5 based systems, wherein it will print me the complete output which will contain on a per process basis what is the user ID which has actually started this particular process, what is the PID, that is the process ID, how much of CPU has been used, how much of memory has been used, what is the virtual process size, what is the resident process size, what is the terminal on which it has been started, what is the current status, whether it is running, whether it is getting sleeping, whether it is currently sleeping waiting for let us say some IO to complete, or whether it is getting paged, or whether it is a zombie process, right. So, when was it started, how much time it has actually run, and what is the corresponding command. So, for every process in the currently running system with these options to the ps command we get all these details displayed which gives a sense of where each command is currently and what kind of resources each command is actually occupying. So, top is another command that will give me the complete process activity on the system. The most important feature of the top command is that for every few seconds, typically like around 5 seconds, the output will be getting automatically refreshed. So, if I really want to find out what are the type of processes that are actually consuming the maximum amount of CPU or the maximum amount of memory at any point in time in my system, then this command is something which is extremely useful for the system administrator, wherein it tries to print out the details in a very dynamic manner and gets continuously refreshed every few seconds or so. So that with this kind of information, the system administrator typically will be able to find out what are the kind of processes that are sort of consuming the maximum amount of resources, right. So, if I want to basically kill a particular task which is actually getting listed in the top output, I could just press the key K and then followed by the process ID, and then it will automatically try to kill that particular process, assuming that this particular person has permission to kill the process. So, otherwise I could also get the process killed by using different commands. I could use kill followed by the PIDs. So, the kill command followed by the PIDs will try to send a kill signal to each of those PIDs. So, when I say kill -9 followed by the PIDs, it will send an immediate termination signal, what we call as a sig term, to each of the process IDs that is mentioned here, and assuming that the user who is running the kill command has permission to kill that particular process ID, or if he is a super user. So, if either of this condition is satisfied, then that particular set of PIDs that is mentioned here, one or more PIDs that is mentioned here will be killed successfully by the system. So, if I say kill -9 -1, it will kill all the processes of the current user that is being currently run. So, if a user called user1 has actually logged in and he has started like 5 different commands or 5 different applications, and after that if he is basically running the command called kill -9 -1, all those processes applications will be getting killed, and then he will come back to the state whatever he was in before even he had actually logged in into the system, because even the shell command that was actually available to him as part of a successful login, that also will be getting killed if this particular command kill is run with -9 and -1. The shell process also is a process started by that particular user, because of which the shell process also will be getting killed with this particular command. Alternatively, we can also run killall or xkill to kill all the processes which are running this particular command. Again I should have permission as a super user typically, or as a normal user, if all the commands that are running as processes right now have been started by me, then I will be able to run the killall command successfully on all those processes, right. Xkill is actually used to kill any kind of a graphical application that you might be running. So, the next way of the way that I typically use commands as part of the job control is running them in a sequential manner. So, what we mean by a sequential manner is, if I want to run multiple commands together in a single command line, I could use a semicolon as a separator and then run them. So, here it will first run the command echo that is given here in this example, and since there is a semicolon, it will try to run the second command, then there is a semicolon, it will run the third command. So, in this case, each command which has been given in the command line delimited by a semicolon will be run one after the other by the shell, and in that way it is also a sort of a job control wherein they are run one after the other sequentially, even though there have been multiple commands given in a single command line. Now, another way of running the sequential commands is using what is called as a logical or the logical AND operator. When each of those commands run and when they do not run is actually dependent on what is the status of the previous command execution. So, if I basically say that I want to run this first command more God, so it will try to display the contents of this file called God, and if that particular command is not successful, when will it not be successful? When this particular file is not existing, right. What it will actually do is, it will now encounter the logical OR. So, as far as the truth table of OR is concerned, the overall value, result value of the entire expression is true if either one is actually true, right. So, because of the fact that the first one that has been given as part of this logical OR expression is false, in a scenario where this particular file is not existing, the shell will actually try to go and execute the second command that is actually being given here, right. And what is the command that is actually being given here? It is an echo command wherein this particular message is going to be getting displayed, right. On the other hand, if the first one was successful, because of the fact that one of them has been successful out of the first command or the second command, the shell will not go and execute the second command, because for the logical truth table of an OR condition, if one of them is true, then it is actually sufficient, right. So, in this particular scenario, the second command is actually going to be getting executed only if the first one is actually failing. On the other hand, when we actually say we want to use the AND operator, the AND operator will be run only if the previous one has been successful, because like we were seeing the truth table of the OR condition, for the AND condition the truth table essentially means that the whole value is true only if the resultant sub expressions are true. So, in this particular case, if you see, we have said that we want to list the contents of the home directory of the SD6 user, and if, for example, if this SD6 user is not existing or the home directory is not existing, there is no point in trying to list the contents of the subdirectories or files of this home directory, right. So, that is the reason why the logical AND operator is used here. So, if this was successful, then I will have the second command getting executed also, and the output of this command is also redirected to another file. So, because of the fact that the logical truth table value of an AND operation will be 1 only if both of them are 1, only if the first command is actually successful, the shell will try to go ahead and execute the second part of the logical conditional operator expression, and if this was non successful for any reason, maybe the SD6 was not a valid user, because we are trying to, with the user is a tilde character, we are trying to refer to the home directory of the SD6 user. So, if SD6 user is non-existent user, there will be no home directory of SD6 user, or if the SD6 user is a real user, but there has been no home directory configured for this particular user, in either case this condition will fail. If this condition fails, then there is no point in actually running it, and therefore we are using the AND operator here, and because for the AND operation both of them has to be successful, and in this particular case this has been a failure, the shell will not try to run the second part of the second expression that has been given here also. On the other hand, if this has been a successful, wherein the SD6 is a valid user and we also have a home directory for the SD6 user, then the shell will actually try to run the second part of the expression also, because the AND operation is given, and this AND operation will be running when we have the first part of the expression to be a true resultant value. So, in this way we can actually use a conditional operator like or AND to make the commands executed in a sequential manner depending on what has been the output of the previous command. The next command can either be run or not be run by using the appropriate logical conditional operator. Thank you.